चलो फर्स्ट वन बेटा concept of displacement wave. Concept of your displacement current represented by ID. Okay, so just roughly I'm telling you better. Like say these are two capacitors in between which there is a vacuum. And these two capacitors are being connected to an alternating source of your current. This is a symbol of your AC better. Okay, and charge on this one is plus Q and charge on this one is negative. So charge on this plate will be positive and charge on this one will be equal to negative. The current which has been passing through this one is right now for me conduction current. That is nothing but IC. Okay. The moment there is a flow of a current through this one beta, for our surprise, we found that there is a complete current even flowing between these two capacitors. That current which is been flowing through this capacitor is called as of your displacement current. Now I'm not going behind the story what exactly is happening, that all phenomena. Just remember that even though there was a vacuum or there is no connection between the capacitor and positive charge and negative charge, because of an electric current or electric field, a new current has been developed between the two capacitors. That current we are calling it as of what for me? Displacement current. Okay now. Okay, that means I can say that in wire, what is the displacement current beta? Displacement current will be equal to your zero. Conduction current will be not equal to your zero. Whereas in between these two plates, in between these two, if I'm taking, conduction current is equals to zero, but displacement current is not equal to zero. So in a wire, there is only conduction current beta. There is no displacement current. Because of the change of your electric lines in between them, if current is being produced. So that means flux is equals to E bar dot A bar. If formula between the capacitors, because of the change in the electric field passing through that given area, a flux is being created. That is equals to E bar dot A bar. Clear? Now, how do you define the conduction current beta? Conduction current is nothing but simply dq divided by dt. Am I clear? Anyone remember the displacement current beta? What is the displacement current? Displacement current is equals to epsilon naught into your d phi due to the electric field divided by dt. This is your displacement current. Clear? So displacement current is very important formula. Epsilon naught into d phi e divided by your dt. Conduction current ante telisinde. So that means in this chapter, we are going to see that displacement current is numerically equal to your conduction current. Then only there is a flow of your current. This is your Ampere's Maxwell's law. So first law, what you are writing here is right now for me, Maxwell's Ampere's law. Maxwell's Ampere's law. Maxwell Ampere's law says that whenever there is a flow of a current, it is because of both conduction and displacement. That is line integral of your B bar into your DL bar is equals to your mu naught into current due to conduction current plus of your displacement current. This is your Maxwell's Ampere circuit law. Clear? That means I can write this one as line integral of your B bar dot your DL bar is equals to your mu naught into, this one is right now for me, conduction current plus displacement current is epsilon naught into d phi e divided by dt. So this will be your displacement current. Yeah. So this is your displacement. Clear, madam? So what is an Ampere's Maxwell's Ampere circuit law? Line integral of a B bar is equals to mu naught plus of your conduction current. Mu naught line integral of B bar into DL is equals to mu naught into IC plus ID. Am I clear? Am I clear? Sure. The next one and very important. Nature of electromagnetic wave. What is the nature of your electromagnetic wave? Can anyone tell me, madam? Nature of an electromagnetic wave is both electric and as well as of your magnetic. Okay. So if I talk about this wave right now for me, so one wave is like this. Like this. Okay. That means it is moving parallel to your y-axis. Okay. This one is your x-axis and this is your y-axis. On y-axis, we are taking the electric field beta, E bar. On x-axis, we are taking the speed of light. That is nothing but of your C bar. And perpendicular to this one, there is one more field that is nothing but equal to magnetic field. That is right now for me, magnetic field. That is nothing but z-axis. Okay. Now, perpendicular to this one right now, there is one more wave which has been going in the downward direction like this for the given condition in the z-axis like this. Also, I'll draw this one like this, perpendicularly like this. Okay. So this will be in this direction. So that is your magnetic field. Okay. In the direction of a magnetic field is blue line. So what is the nature of this light beta? Speed of the propagation of light is always in x-axis beta. Magnetic field is along your z-axis. Electric field is along your y-axis. What is the nature of this wave? You need to remember transverse nature. Nature of the electromagnetic wave is what for me? Transverse nature. Am I clear? Now see, electric field E bar, magnetic field B bar, and speed of light C bar. All are perpendicular to each other. All are perpendicular to each other. Electric field is along y-axis. Speed of light is going along x-axis. Magnetic field is along your z-axis. Clear? The speed of the light in a medium is given by the formula. I hope you remember this one. V in a medium, speed of the light in a medium is equals to 1 by under root of your mu of medium and epsilon naught of your medium. So that will be equal to your right now for me. So what is the given condition, beta? C divided by mu. Mu is the refractive index. So this is your speed of your light. Clear? Mu is your permeability of the medium. Epsilon IM is right now for me. Permittivity of your medium. Clear? Now see. The direction of this one, E bar cross B bar, is always equals to speed of light. And the ratio of electric field divided by magnetic field is equals to your C. Okay. So what I mean to say is, if E bar cross B bar is given, that is always parallel to your speed of your light. Okay. Ratio of your electric field divided by magnetic field will be equal to your speed of your light. And speed of light in vacuum is given by the formula 1 by under root of your mu naught into epsilon naught. And what is the speed of light, beta? Speed of light is 3 into 10 to the power of 8 meter per second in the vacuum or in the air. Am I clear with this one? So this is the box which you should always be committed to the memory. Clear? The product of E bar cross B bar is parallel to the speed of light. A ratio of electric field divided by magnetic field is equal to speed of light. And speed of light in vacuum is given by the formula C is equal to 1 by under root of your mu naught into epsilon naught. And speed of light is equal to 3 into 10 to the power of your 8 meter per second. Am I clear?
Yes.
To understand this one, I just need the basic knowledge of vectors. Basics of vectors. It is also applicable for your magnetic fields beta. Like say for example, if I'm having here I, this one is your J, and this one is right now for me K. If I'm moving right now for this one in this direction, if I'm moving from C to J, J to K, and K to I, which direction it is? Clockwise. In clockwise direction, you always take it as positive. Okay, like in this one, if I'm writing I bar cross J bar will give me what beta? Plus K cap. J cap cross K cap will give me what beta? Plus I cap. And K cap cross I cap will give me what beta? J cap. Without this knowledge, we can't do the problems of your, what do you call that one? Electromagnetic waves. Clear? In the same way. And if I'm going in anti-clockwise direction, okay, I'm having right now here I, this one is your J, and here it is right now for me K cap. Okay, and I'm moving in the anti-clockwise direction. Okay, like this. Arrow markers like this. Okay, now tell me. If I'm writing this relation right now, beta, I cap across K cap. So this one is right now for me anti-clockwise. In anti-clockwise, we take it as negative. Okay. So in this one, if I'm writing this relation here right now, give me the answer. I cap cross of your K cap. What will be the answer, beta? I cap cross of your K cap will be equal to minus of your J cap. The same way, J cap cross of your I cap will be equal to minus of K cap. In the same way, K cap cross of your J cap will be equal to minus of your I cap. Clear? This is the basic thing you need to remember, beta. In the clockwise direction, I'm taking positive. In anti-clockwise direction, I'm taking the negative. Am I clear? So give me the answer for this one faster. If electric field is in x-axis, positive x-axis, speed of light is along your z-axis, a cap, and magnetic field will be in which direction? But can anyone tell me? Magnetic field is along your j cap. All of them are perpendicular to each other. So I told you that E bar cross B bar, E bar cross B bar will be parallel to your C bar. That means E bar is in which direction? Beta? I cap cross B bar is your J cap. I cap cross J cap will be equal to how much for me? K cap. That means the speed of the light is in your K cap. Am I clear?
Yes, sir.
Isn't it? Sure. One more question. If I say that magnetic field is equals to in minus of J cap beta, and speed of the electromagnetic wave is in your minus of your I cap. Clear? Or plus of your I cap. Tell me what is the electric field direction. Anyone? B is given and I is given. Faster. E bar cross B bar is equals to your magnetic field is given for me. Electric field has been given for me. So when I'm taking the product of your E bar cross B bar, in which direction it is better? Tell me.
K cap.
Plus K or minus K? See, if I need the electric field, and here
Minus.
I'm having the magnetic field, and here I'm having the C. E bar cross B bar will give me the C bar. That means E is in which direction? B is how much for me? Minus of j cap. And C is right now for me or I cap. Isn't it? So obviously if I'm writing this relation beta, K cap across of your minus of j cap or K cap across of your minus of j cap will be equal to how much beta? K cap cross of your minus of your j cap. What will be this one? Plus of your I cap. That means electric field should be in which direction beta? K cap. So E bar must be equal to along your plus of your K cap. Clear? Am I clear? Done beta?
Not understood, sir.
Now, what is the given conditions you take beta? Just take the vector product right now there. I'm writing here, you see. B vector is given how much for me? Minus of j cap. And this one is right now for me k cap. Cross of your I cap. Minus j cap cross I cap is giving what beta? You see here? Minus of your j cap cross of your k cap. Minus of your j. K cap will be equal to, if I take the I cap in opposite direction. Minus of j cap cross of your I cap will give me how much? Just take in cross product. E bar cross B bar must be equal to E bar cross of your B bar must be equal to what? Parallel to your C bar only, na? Isn't it?
Yes, sir.
Now B bar is given how much for me? Minus of your J cap, and C bar is already given how much for me beta? Plus of your I cap. Now for me, what if I multiply with your vector here? I'll be getting the plus J. It is minus J and it is your I. So what I should multiply here so that I'll be getting the plus I right now here. Okay, like say if I take E bar as of your K cross minus of J cap, this will be minus of I cap. That means this will be equal to plus I cap. That means electric field should have been in which direction beta? Positive K cap. Positive K cap across minus of J cap will give me what? Positive I cap. I cap is in which direction beta? Always in the speed of the light x-axis. So to get the positive I cap, the direction of the electric field should be in which direction? K cap. Got it?
Yes, sir.
Okay.
Yes, sir.
Okay. I'll give you one more question in the question format. You please try to do it always. Like say for example, we got an electromagnetic wave. Electromagnetic wave is propagating in a medium. Think and give me the answer. With a velocity, V bar is equals to V into I cap. Okay. The instantaneous oscillating electric field. Oscillating electric field of electromagnetic wave is along positive y-axis. Okay. Then the direction of oscillating magnetic field. Oscillating magnetic field of electromagnetic wave will be. Okay. Now read the question once again. I'm giving you the options. First option is negative z direction. Second option is positive z direction. Third option is negative y direction. And fourth option is negative x direction. Okay. Now read the question. Don't bother about the. Sorry. An electromagnetic wave is propagating in a medium with what speed beta? Speed of the light. That means C bar is given for me. C bar is equals to V times of I cap. That means the speed of the light is in which direction, beta? X-axis. This is your I cap. This is your J cap. And perpendicular to this one will be equal to K cap. Isn't it? So now what is telling? Electromagnetic wave is propagating in a medium with a velocity V is equals to your VI cap. The instantaneous oscillating electric field of electromagnetic wave is along your y-axis. That means electric field is along this direction, J cap. Then what will be the direction of your magnetic field? What will be the direction of your magnetic field? And make sure that always the electric field cross B bar will be parallel to your C bar. The product of E bar cross B bar must be parallel to your C bar. E bar cross B bar means like we take the vector A bar cross B bar is equals to mod A mod B into your sin theta. How do you give the direction of this one better? Take your right hand. This is the vector A bar and this is the vector B bar. And rotate your fingers from A bar to B bar. The resultant is along C bar. C bar is what for me? A bar cross B bar. The same way here. Electric field is along Y direction. Take your right hand, keep the fingers in the direction of your J cap. Now in which direction I should rotate the fingers such that the thumb will give me the direction of your speed of the light. That means it should be in the direction of your I cap. So what should be the direction of your magnetic field? In which direction?
That's it.
Electric field is in which direction, beta? J cap cross. This was a direction I don't know. The resultant is in which direction, beta? I cap. Because in the problem I is given, electric field is given. Then the B should be in which direction so that I will be getting I cap beta. That is the reason I told you here. J bar cross K bar. J bar cross K bar will give me what? I cap. Am I clear? That means the direction of your magnetic field should be in which direction, beta? Anyone? It should be in the direction of your what?
Minus I cap.
Y minus J cap cross K cap will give me I cap, na beta?
Positive side.
Speed of the light is already given in x-axis. That means already speed of the light is along your x-axis. Electric field is along y-axis. What should be the value of magnetic field so that I'll be getting plus I? See here right now, I just told you here. J cap cross K cap is giving plus I cap. That means the magnetic field should be in which direction? Positive Z direction. Am I clear? Am I clear? Done, beta?
Yeah.
Any doubt in this one?
No doubt, sir.
So these vectors you need to little bit practice it better. You should make your what you call that one speed more in this one. I cap cross J cap plus. If I take opposite J cap cross I cap minus K like that, you need to remember all these relations. That is the reason this clockwise and anti-clockwise I had on. Whenever some electric fields are being given, just try to draw this diagram and accordingly you try to identify the directions. Am I clear? Sure. The next one, a very important formula. Energy density of electromagnetic wave. Energy density of your electromagnetic wave. Electromagnetic wave is a combination of what beta? Both electric field and magnetic field, na? Isn't it? So if I'm writing first one is average energy density of electric field. UE is equals to, this one is half epsilon naught into ERMS square. Or that is equals to your half into epsilon naught into E naught divided by root 2 whole square. Always remember beta, ERMS is equals to E naught divided by root 2. BRMS is equals to B naught divided by root 2. ERMS means root mean square speed of the magnetic field. B naught is nothing but peak magnetic field. E naught is known as of your peak electric field. Am I clear? This formulas you need to be by heart this one beta. ERMS is E naught by root 2 and BRMS is equal to B naught by root 2. What is B naught? Peak value of magnetic field. What is E naught? Peak value of electric field. Am I clear? Am I clear? So this value will be equal to 1 by 4 times of epsilon naught into E naught square. This is the formula. What is the average energy density of electric field? So I can write here energy density will be equal to how much, beta? Energy density every time, beta. Energy density is always equals to your energy divided by volume. Throughout the physics, whenever we get energy density, it should be understand that it is the ratio of energy per unit volume. U is nothing but what, beta? Average energy density of electric field. U is right now for me average energy density of electric field. Direct to Adogocho. If your luck is very good, he may directly ask you only the formula. Identify the energy average energy density of electric field. Clear? So energy density formula is what? Energy density is always equals to energy divided by volume. Average energy density of electric field is 1 by 4 times of E naught epsilon naught into E naught square. E naught is the peak electric field. Epsilon naught is nothing but what? Permittivity of your free space. Am I clear? Am I clear with this formula? The next one. As electromagnetic wave is a combination of electric and magnetic field, the same way I can calculate here average energy density of magnetic field of your magnetic field. Gursunda formula ever karna? Average energy density of the magnetic field is equals to BRMS square divided by 2 times of mu naught. That is equals to B naught divided by root 2 whole square divided by 2 times of mu naught. And this will be equal to B naught square divided by 4 times of your mu naught. So this is your average energy density of your magnetic field. Average energy density. By heart, Edgar, you need to remember this formula better. Clear? And as it is a combination of electric and magnetic field beta, you can say that energy density of electric field will be equal to energy density of magnetic field. U small u represents the energy density beta. Energy density is represented by letter small u. Am I clear? So I can say that energy in the electric field will be equal to how much for me? Energy in the magnetic field. I'll write here. Energy in electric field is equals to energy in magnetic field. Energy in your magnetic field. Clear? Okay. Now tell me, what is the total energy density beta? Total average energy density of what? Electromagnetic wave. ఎంత అవుతుంది చెప్పండి? Total is combination of your electric field plus of your magnetic field value. Energy density. So energy density and I'll write in terms of what? Small u. So energy density, total energy density is equals to electric plus of your magnetic. So if I add both of them as they are same, it will be 2 times of energy density of electric field, or it may be 2 times of the energy density of your magnetic field. That means this value may be equal to half into epsilon naught into E naught square, or that will be equal to your half into B naught square divided by mu naught. Very, very important formula beta. Total average energy density of electromagnetic wave is 2 times of energy density of electric field or 2 times the energy density of magnetic field. So value of that one will be equal to half into epsilon naught into E naught square or half into B naught square divided by mu naught. Okay. Can anyone tell me the units of energy density of electric and magnetic field beta? Units of energy density of electric field and energy density of magnetic field. As it is energy per unit volume, unit of energy is joule and volume is right now for me meter cube. Energy per your unit volume, that is meter cube. So it is joule per meter cube will be the unit of this. Am I clear? Am I clear?
Yes, sir.
Just Very important, Nana. Just give 1 hour of 1 day or 2 hours of time on this topic. You will become perfect. Just try to do the way I'm trying to write all the formulas and just try to concentrate on your PYQs. That's more than enough. Okay. So first formula is displacement formula. Displacement current formula ID is equals to epsilon naught into d phi E by dt. You should remember the displacement current will be equal to conduction current. Actually, if you go for the explanation, it is a very good explanation, beta. But we don't have the time, so don't bother about of that all logic here right now. Ampere's circuital law. Maxwell's Ampere's circuital law is line integral of b bar into dl is equals to mu naught into conduction current plus of your displacement current. Nature of electromagnetic wave, it is both electric magnetic field, and the electric field and magnetic field will always be parallel. Resultant of electric and magnetic field is always parallel to your speed of the light. They are always perpendicular to each other. So speed of light in the medium is given by c by mu. Mu is the refractive index, c is the speed of light, or it is 1 by mu of your medium and epsilon naught of your medium. And remember that resultant of electric field and magnetic field is always parallel to the speed of light. The ratio of electric field divided by magnetic field is equals to speed of light. C in the medium will be equal to. So this is for your vacuum bit. So this is for your vacuum or air. C for speed of the light in vacuum or air is 1 by under root of mu naught into epsilon naught. And the speed of light is 3 into 10 to the power of 8 meter per second. Just go through the basics of vectors. Then energy density. Energy density of the electric field is 1 by 4 epsilon naught into E naught square. E naught is known as peak value of electric field. Average energy density of the magnetic field is V naught square divided by 4 times. And you would remember that average energy density of electric field is always equals to your energy density of the magnetic field. So if I'm adding both of them, I'll be getting the total energy. Total energy is 2 times of energy density of electric field, or it will be 2 times of the energy density of magnetic field. That formula for the total energy is how much? Half into epsilon naught into E naught square. If your magnetic field is given, it will be half into B naught square divided by mu naught. Okay, what is the value of mu naught, beta? Mu naught value is 4 pi into 10 to the power of minus how much? Chapala. Mu naught value 4 pi into 10 to the power of ఏమైంది 1 by 4 by epsilon naught value ఎంత నాన్న
9 into 10 power 9.
half into mu naught value ఎంత ఇస్తుంది చెప్పండి సార్ what is the value of mu naught? Mu naught is equals to 4 pi into 10 to the power of minus 9 7
9.
1 by 4 by epsilon naught value
9 into 10 power 9.
9 into 10 to the power of 9. Mu naught value is చెప్పాలా constant value na if you don't remember the constant value ఎట్లా చెప్పండి what is the unit of mu naught beta magnetic permeability Henry per meter mu naught value is 4 pi into 10 to the power of minus 7 అమ్మో అది కూడా రాయాలట్లయితే నేను mu naught value is equals to 4 pi into 10 to the power of minus 7 clear and next one again very important formula beta that is intensity of electromagnetic wave. What is the intensity of your electromagnetic wave? Formula gurtunda intensity is equals to your power divided by area. I told you this one in the dual nature also. For spherical bodies, it will be P divided by 4 pi into your R square. R that is also equal to your average energy density multiplied by speed of light. Or intensity is also equal to I is also equal to half into epsilon naught into E naught square multiplied by speed of light. Very important formula beta. In terms of magnetic field, intensity will be equal to your 1 by 2 times of your mu naught into your B naught square multiplied by your speed of light. Clear? Our intensity is also equal to your 1 by 2 times of mu naught into your This is E naught square divided by C. Okay. Am I clear?
Sir, what is the first formula? Half into?
Epsilon or not. Permittivity. Epsilon naught is nothing but what we need? Permittivity of free space. Permittivity of free space. Mu naught is nothing but permeability. Permeability of your free space. C is equals to speed of light. Clear?
Yes, sir.
Sure. E naught is known as peak value of electric field. Peak value of electric field and a maximum value. B naught is nothing but peak value of magnetic field. Clear? Intensity is also equal to 1 by 2 mu naught into E naught square divided by C. Because what I told you, E divided by B will be equal to how much for me? ఇంతకు ముందు నేర్చుకున్నాం మనం. Electric field divided by magnetic field will be equal to speed of light. Okay. Am I clear? So in this one, I eliminated the magnetic field. If I eliminate the magnetic field in terms of speed of light, so B value will be equal to E by C. So it is E square divided by C square. One C will get cancelled. So that is the reason I got this value. Clear? So this all formulas should be committed to your memory. You can't sit and derive in examination hall. The more you write it in your paper and stick out to your place where you are sleeping, that will always be helpful. Don't take it light, beta. They are very, very important, beta. Intensity is equals to power by area, or it is average intensity into your speed of your light. Then ఇంట్లో కూడా రాసుకోవచ్చు. Intensity is also equal to anyone better. Power can be written as what? Energy divided by time. So it is your energy divided by time multiplied by your area. Okay. So intensity is equals to energy divided by time multiplied by your area. Am I clear? Am I clear? PYQ చాలా తక్కువ ఉంటాయి నాన్న, అది కంపల్సరీ ఈరోజు అయిపోగొట్టండి కంపల్సరీ. ఎట్ ఎనీ కాస్ట్ యూ నీడ్ టు కంప్లీట్ దిస్ వన్. ఏమంటున్నాను? చలో. చాప్టర్ నేను ఇది కంపల్సరీ చేయాలి ఒకసారి. Because examinations చేసేటప్పుడు we are getting problems on electromagnetic waves. We are leaving them. Okay, today I will be completing electromagnetic waves and evening class. Most probably, if it is possible, I'll do the current electricity later, beta, because I'm little bit getting bored because I taught almost like 4-5 times for different batches. I'll take some time. I'll try to do it out. Okay, and don't bother about that one. The one who has been not attended, I'll do that one in detail so that it will not be ineffective. Okay, so it will not be much what do you call that one, like fast running or something like that. I'll try to do it in detail so that you can be in a position to do the numericals. Electromagnetic wave chinna topic. So half an hour, 1 hour if we give for the self study, you can get the scoring top what do you call that one, marks in this chapter. Clear? Sure. Next heading, Renan. That is momentum of electromagnetic wave. Momentum of your electromagnetic waves. Momentum of your electromagnetic waves. So what is the momentum formula, beta? I already told you. I'll write little bit figure one. Momentum is represented by P. Momentum is equals to energy divided by C, speed of light. P is equals to U divided by C. Okay. U is your total energy, beta. What is U? U is equals to your total energy. And C is equals to your speed of light. Speed of electromagnetic wave. That is light. And P is your momentum, beta. Okay. So if I'm talking about first one is perfectly reflecting or perfectly observing. Perfectly absorbing surface. When a light is being incident on that one, and if it is totally absorbed, then in that case, the momentum is given by the formula. Change in momentum is always equals to U divided by C. Clear? In the same way, if I'm talking about perfectly reflecting surface, for your perfectly reflecting surface, like mirror, when a ray of light is being incident on a mirror, it will be reflecting back. In that one, the change in momentum will be equal to how much better? 2U divided by C. Momentum, the dual nature lo cheppanu nenu idi meeku. Am I clear? Sure. The next one is radiation pressure. Radiation pressure. This all I told you in the dual nature. ఇవన్నీ by hearted గా ఉండాలన్న మీకు. You should always be by hearted in your tips of your hand for doing the numericals. Number one, P is your pressure beta, not your power. Pressure is equals to your intensity divided by your C, speed of light. Or that is nothing but of your area vector, pointing vector divided by speed of light. This is for your perfectly absorbing surface. For your perfectly absorbing surface. In the same way, pressure will be equal to your 2I divided by C. Or that is equals to 2 times of mod of your S divided by C. This is for your perfectly reflecting surface. Perfectly reflecting surface. Very important formula as well. P is equals to I by C, or P is equals to 2I divided by C. Or P is equals to pointing vector divided by C, 2 times of pointing vector divided by C. What is P here, beta? Anyone? This P is nothing but what for me? Pressure, not power. This one is also your pressure divided by speed of light. Intensity divided by speed of light. So P is your pressure. I is what beta here? I is equals to intensity. Clear? Done, beta?
Yes, sir.
See this question. Light with an energy flux. With an energy flux of 25 into 10 to the power of 4 watt per meter square. And what is nothing but unit of what? Power divided by meter square is unit of area. Power by area. Ante energy flux is nothing but equal to what? Intensity. Okay. Light wave with energy flux of 25 into 10 to the power of 4 watt per meter square falls on a perfectly reflecting surface. On a perfectly reflecting surface at normal incidence. At normal incidence. Clear? If the surface area is 15 centimeters square, the average force exerted on the surface is this is the question. First option given for me is 1.25 into 10 to the power of minus 6 Newton. Neat lo sir adina question anedi 2.50 into 10 to the power of minus 6 Newton. Third one is 1.20 into 10 to the power of minus 6 Newton. And fourth option for this one is given as of your 3.0 into 10 to the power of minus 6 Newton. Now read the question carefully. Light with an energy flux. Now I told you what do you mean by energy flux? What do you mean by energy flux? Energy flux is nothing but equal to what? Power by area. That is nothing but intensity. Clear? Falls on a perfectly reflecting surface at normal incidence. If the surface area is 15 meters per second, 15 centimeters square, the average force will be equal to how much? Anyone? Reflecting surface means what? P is equals to 2I divided.
2U by
P is nothing but what here? Pressure in terms of intensity. So it is 2 into intensity is how much for me? 25 into 10 to the power of 4 divided by speed of light. 3 into 10 to the power of your 8. Clear? So this 4 and this will get cancelled. So here it will be your 4. So P will be equal to 25 to the 50. 50 divided by 3 into 10 to the power of 4. So that will be equal to how much for me? 5 divided by 3 into 10 to the power of 3. Pressure will be equal to how much beta? P is nothing but what for me? Pressure. Pressure is equal to what beta? Force divided by area. That is equals to 5 divided by 3 into 10 to the power of 3. So we need to calculate the force. So it is force divided by area is 15 centimeters square is telling. And then area is 15 centimeters square. So it is 15 into 10 to the power of minus 2 whole square. And then centimeter square means minus of 4. So that will be equal to your 5 divided by 3 into 10 to the power of 3. Then, so this 3 ones are this 5 and this 5. Sorry, this will go up. Getting stuck here. Okay, so it is 3 ones and here it will be equal to your 3 5s. So it will go up there right now. So I need to calculate the force. So F value will be equal to 5 5s are 25 divided by 10 power 3. Okay, and this power is also going up. It is 10 power minus 4. So it is your 25 into 10 to the power of minus 7. So this will be equal to 2.5 into 10 power minus 6. This will be the answer. See whether there is option 2.50 into 10 power minus 6. Second option will be the answer. Got it?
Yes, sir.
Almost all the formulas have been covered. We just need to take some time and need to reproduce it. This should always be on the tip and you will be getting little bit confusion related to the P, whether you need to take the pressure or your power, that you need to write it without seeing twice and thrice, then only you can able to do. Already ఒకసారి చదివింటే it will be a sort of revision. చదవకపోతే you can take 1 hour of a time and try to just go through these formulas and try to do the PYQs. ఈఆర్ఎంఎస్ విఆర్ఎంఎస్ ఎక్కడ వచ్చాయంటే అది ఏసీలో వస్తాయి, కానీ ఇక్కడ మాత్రం యాజ్ ఇట్ ఈస్ గా గుర్తుపెట్టుకోండి. ఆర్ఎంఎస్ వాల్యూ ఆఫ్ ది ఎలక్ట్రిక్ ఫీల్డ్ అంటే ఈ నాట్ డివైడెడ్ బై 2 √2 and BRMS will be equal to V naught divided by √2. And the directions are important, Anna. You need to revise this one twice and thrice with the help of your vectors and try to do some problems. And we need to take even the help of your wave equation formulas, that I'll try to do it in the 10 o'clock class. So today I'll continue with your electromagnetic waves at the 10 o'clock class and try to complete and try to revise even some waves concepts so that some wave problems have been associated. And I'll try to write all the formulas in this. Am I clear?
Yes, sir.
Any doubt in this one?
No.
I have sent you 2 papers, beta. AITS 10 and AITS 11. You please try to take physics at 45 questions and try to do 25 questions from the given topic. Now you can check once the questions of electromagnetic waves also, beta, once. Okay? With a small topic has been left out, that I'll try to do it at your 10 o'clock session of the class. Don't try to miss that class. So we'll try to give the first off for this 4 marks or 8 marks. Your final. Last year I did 8 marks at electromagnetic waves law 2024. Okay, na? 23 lo kuda 8 marks unde.
Okay.
This year we may expect only 1 question because of the reducing the number of questions. Okay, displacement current is fine. Man koni problems cheddam with respect to the capacitors and applications. Then we'll try to do some of the other formulas of Gauss laws of your electric field, magnetic field, all the formulas in one set, and some properties of your electromagnetic waves, which are very, very important. But all I'll try to do it out in the 10 o'clock session of your class. Okay, అప్పటి వరకు ఒకసారి టైం దొరికితే have your dinner and try to take your PYQ book and at least try to complete your 4-5 questions or at least 10 questions in the electromagnetic waves. Just go through these notes. I'll send you these notes right now. Okay. Sure. Take care, beta. Bye.